on to see how I did? Like, see what I put down as answers?
I don't, because I usually write down the answers before I close out the quiz.
Oh, really?
Yeah.
I usually do too, but yesterday I was obviously in a hurry, and so
Yeah. Yeah, so I don't know how you do it afterwards.
Okay.
Maybe can you go to where it talks about where it shows your, let me pull this down so I can see it. Let's see. Go to this and see if I see where you can. Okay. I guess I don't need both screens up since I can't see your face this morning. So
Yeah.
works out. Okay. My son is heading to Hawaii in a week and a half, I think.
Mm-hmm.
He graduates on the 17th, and then the 18th they're heading there for.
Really?
Yeah, they're going for 10 days, so I get the grandbaby for 10 days.
Ooh, that'll be good for you too.
Yeah. Okay, so I'm wondering if we go to grades. Go to group meeting quiz. Nope. Okay.
No.
What I was thinking where you could, I was thinking maybe you could pull them up there, but it doesn't let you.
Mm-hmm.
So I don't know how you do. So.
Oh, I found it now.
Did you? Oh, good.
So.
How do you get there?
So if you go to under the grades tab and you go to user progress.
Uh-huh.
And then you, on the left side, you'll go all the way down to, you'll see quizzes. If you click on that, oh, I think this is it. I could be wrong. We're on lesson 15?
Yeah. Yep. Oh, look at that.
Oh, maybe not. That just takes me to the same page.
Oh, it doesn't let you see it?
There's gotta be a way. How did you do on the quiz?
I got an 86%.
Okay, I got an 80.
So
I'm sure I have some right and you have some right and do good, but
yeah, I got 5 of them wrong. So
5 of them?
yeah. Let's see. 15 details. Okay. I'm seeing. Okay, this is how you do it.
Awesome.
Find your lesson 15 group quiz.
Under grades or?
On that progress that you told me to go to.
Okay.
And go to the quizzes and then scroll down to lesson 15 group meeting quiz. And then you can click on details.
Lesson 15. Okay, details.
And then attempt 1, click on that.
There it is.
Yep.
Awesome. You're a lifesaver.
I don't know about that. Oh, I guess we should start with prayer, huh? We're supposed to do that.
Yes, yeah.
Okay. I'll go ahead and say the prayer.
Okay, sounds good.
Our dear Father in heaven, we are grateful for the opportunity that we have to meet together to go over our quiz and what we have learned in the class and to help each other through this. And we are grateful for the opportunity of our education. And we ask a blessing to be upon those of our teammates and watch over them and help them where they are needed. And these things we ask for in the name of Jesus Christ. Amen.
Amen. Cool.
All right. I guess I should watch too to see if Mitch joins, because I saw that he joined you guys last time. And
Yeah, I didn't say anything.
yeah.
That was kind of funny. All right. So there wasn't a preparation assignment to go over.
Nope. We just have the quiz here. So
We got the exam today.
okay, I'm going to pull this up in case I see Mitch show up at the bottom here.
Okay.
We can have him help us. Okay.
All right. Did you open the quiz back up?
Yeah, I have it back up.
So I can start with question 2.
Okay.
Given a 90% confidence interval of 45 to 105 for men heart rate, which of the following is best interpretation of confidence interval? And I put the second one. We are 90% confident that the true mean heart rate is between 45 and 105.
Yeah. Okay. And then number 3. Okay. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus in males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no-go stimulus required the students to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? And I put, let's see, the last one. No, sorry, the third one. Yes.
The third one?
Yeah.
That's right. All right, question 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? The confidence interval for mean when sigma is known.
Did you get that one wrong?
I got that one wrong, yeah.
Okay, it's the third one, confidence interval for the difference of means using independent samples.
Okay. Interval for the difference of means. Okay, that makes sense.
Okay, number 5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be $3,402.08 and $4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? And that's to obtain the balances of 90 bank customers rather than 30.
Okay. So I struggled the most with these first few questions. That's where I got all mine wrong.
I got 6, 7, and 8 wrong, so.
Oh, I got them wrong too. So So a factory makes propelled drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution of those standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the drive of the shaft. Input your answers, margin of error, lower bound, upper bound. So what I did here was I used that that Excel sheet, and I used the very first tab on the quantitative inference,
Yeah.
and apparently that did not work. What my answer that I got for the margin of error was 3.182. What did you get?
3.182.
Oh, something. Okay.
Yeah.
Um,
Because I did the same thing, so I don't. Okay. Oh, we need the lower and upper bounds first. Because I was thinking, okay, how did Pete do it? He subtracted and then divided by 2, but we
yeah,
don't have the upper and lower bounds yet.
right.
So, what's
I remember I had another formula for the upper and lower
I was
bound.
going to ask, do you remember the formula for the upper and lower bounds?
Let me check. I had it on my other Excel sheet. Confidence intervals. So it was the upper bound was the sample mean plus the z critical value times the standard deviation divided by the square root of the sample size. Let me see if that works anyway. So estimate the sample mean 1,000. %, which is 1.96. Deviation of 2. Sample size is 4. And so that gives me an upper bound of 1,001.960. Is that what you had for the upper bound before?
No, so that's different. What was it? 1,001,960?
Yes, for the upper bound.
Okay, and so then the lower bound, we just subtract that, right?
Yeah, we do the same thing, but we do it, we subtract the sample mean.
Okay.
And so that would be 998.040.
998 point what?
040.
Okay.
And then for the margin of error,
Are you outside doing the meeting?
sorry?
Are you outside doing the meeting?
No, all the windows are open.
Oh, I was gonna say, I love the sound of all the birds.
Yeah. Yeah, no, it's so nice out here. But the humidity and the heat are killing me. Yeah.
So if we subtract that and then divide it by 2, that should give us the margin of error, correct?
Yeah.
Okay. So, on my calculator. have 10,960 minus 998.040. So we're going to divide this by 2. 1.96.
Yep, that's what I got.
Okay. All right. Well, we'll see if that one works better than the last one.
It's a different answer, so we'll hope so.
Okay. So I'll do number 9.
Okay.
To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation of 0.01. How large should n be so that a 95% confidence interval for the mean has a margin of error of 0.0001, and that is 38,416.
116, yep. All right, question 10. The mean area of several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hired an engineer to measure random. Tell me what the null and alternative hypothesis is. And it's the bottom one. The null is equal to, and the alternative is less than.
Yep. Okay. Number 11. In a statistical test of hypotheses, we say we reject the null with the level of significance alpha if the p-value is less than alpha.
All right. Okay. This talks about a group of students. We collect their GPAs, the anonymous random sample size of 15. With a bell shaped, no outliers. Can they use the ANOVA hypothesis for this? And I put yes. It is enough. The data of the apartment is a bell-shaped curve, and there are no outliers, and the sample variances are nearly equal.
Yep, that's what I got. Okay, so number 13. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has committed a type 1 error.
Yep. If the level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small, what happens to probability of committing a type 2 error? By reducing the probability of a type 1 error, you increase the probability of committing a type 2 error.
That's the first one, correct?
Yeah.
Okay. All right. And this one I got wrong. 15 I got wrong. So
I got it wrong too.
the nicotine content in cigarettes of a certain brand is normally distributed with mean and in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5. But measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis of mean equals 1.5. The alternative is the mean is greater than 1.5. At the 0.05 level of significance, you conclude that you should, and I put fail to reject, but that was wrong.
Yeah, so I did too. I would imagine it's going to be rejected no then, because none of the other ones make sense.
Okay, so we're going to reject it.
Yeah.
Okay.
Because you never put you reject the alternative, and the 5% chance of the null is true doesn't make any sense.
Okay. Sounds good.
Okay. Question 16. You'd like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Independent sample t-test, the second one.
Yep. Okay, 17. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? And it is dependent sampling. If you select a brother so as to compare his academic achievement to his sister, you must include the sister in your for the last one.
That's right. Now, 18, I got wrong.
Okay.
Did you get this one wrong?
No, I got it right.
Okay. A soil scientist collects random soil samples from a field. 95%. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? So I put the confidence interval for mean when sigma is known, but that was wrong. So I'd imagine it's the confidence interval for mean when sigma is unknown.
Yeah, that's what it is. Yeah. Yep.
Cool.
So 19. Which of the following is the 95% confidence interval for this analysis? Input your answers for the margin of error, lower bound and upper bound. Determine the margin of error for the 95% confidence interval. We're on 19. That's 2.025.
Yep. Put the lower bound would be 11.168.
Yep. And the upper bound is 15.217.
Perfect. 22 of the 4 types of confidence intervals listed below, which one is appropriate for this situation? Confidence intervals for the difference of means using independent samples, the third one.
Yep. Okay. Calculate the 95% confidence interval for the true difference of mean listing price between Hummers from LA and New York. Input your answers for the lower bound and upper bound. So the lower bound is negative 423.238.
Yep. This margin was huge.
It was. I couldn't believe it.
So the upper bound is 5,417.336.
Yep. Okay. So the test we're going to use is an ANOVA.
Right. The test statistic for that one was 7.978.
Yep. And the p-value is 0.002.
And then we are going to the conclusion is that there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups. So the second to last one.
Yep. Okay, so 29. What is the correct hypothesis test for the situation? Sorry, I didn't read that whole paragraph up there.
That's fine.
Dependent samples test.
Yep. Calculate the test statistic was 1.685.
Okay, I put negative 1.685 and I got it wrong. So it's just 1.685?
Yeah.
Okay. So the p-value is 0.096.
Yep. And 32, there's sufficient evidence to conclude that there is a difference in mean cost of tickets purchased 14 days. The second one.
Yep. Okay. All right. We'll submit this. Yeah, we did.
Oh, we still missed 7 and 8.
Oh, I got 100%.
Did you?
Yeah.
Oh, I just missed 8.
What'd you put for 8?
11,001.96.
Let's see. I'm getting there. What I put. 1,000. And
Oh,
196.
that's why I just put an extra one.
Darn it.
That's all right. It was a half a point. I got 98.33.
Hey, all right.
Yeah. Cool.
Okay. Good deal. So,
Painless.
sounds good. So thanks for meeting this morning. Sorry you were in Hawaii doing all that.
Oh, no, that's fine. That's fine. It was good to go from an 80 to a 98, so I'm happy.
Yeah. So we meet tomorrow morning again, right?
Yeah, to go over next Wednesday stuff.
Okay.
Or next Thursday stuff. Or Tuesday. Tuesday, that's it.
Yeah. Oh. Okay. That sounds good. So have fun at the graduation today.
Thank you. Well,
Great time at the beach.
all right. Sounds good. Thank you for all your help. Appreciate it.
Hey, no problem. Thanks, Sean.
All right, we'll talk to you later.
See you later. Bye.